What up, YouTube? So I want to do a quick video. I've been meaning to do this for a long time. I kind of discovered something a while back. Come on, blurry vision. That you can do with a treadmill motor. So here I have a 1.75 horsepower treadmill motor, and what I'm going to do is I'm going to power it up using a regular old 12 volt battery that I brought back from the dead. As you can see, I got a voltmeter on it right here. There it is. 11.94 volts. Nothing special, just a little 12 volt battery. Nothing is going to be in between this motor and the battery, just literally hooking it directly to it. Just doing something a little funny. So first, to show you how it runs on just the 12 volts, we're going to set this up. I'm going to see if I can do this with one hand. This is the positive from the battery, and this is the negative from the battery. The negative's hooked up already to the motor, and then now we're going to hook up the positive. And you can see how it runs. Okay, that's the speed, and that's the noise. I mean, that's how it runs on just the 12 volt battery alone. Directly to it. Okay, and it's a 90 volt motor, so it don't spin up to full speed unless you get up to 90 volts to it. So what I've done, we're going to disconnect that. What I've done is I've drilled a hole right here in the side of the motor. I don't know if you can see in there, that's the commutator where the brushes touch the ring in there. So I basically plopped a hole real close to this brush. There's a brush on the opposite side of the motor over here, and another brush right here, and I just put a hole right here. So this is the negative to the battery. So we're going to keep the negative on the battery, and I've got a voltmeter, one side of another voltmeter right here hooked up to it. Okay, now we're going to take the positive to the motor, and we're going to hook up the other side of this voltmeter right here. Okay, give me just a second. If I can get this in here. Well, I'll use this. Hold on, bear with me. Okay. Dang it. Okay. Positive is hooked up and the negative. That's just the negative is hooked up to the battery and the positive side is hooked up just to the voltmeter. The battery is not hooked up to the treadmill motor. Okay, it's right here. So I'm going to take this little jumper wire I got right here. If I can find it. There we go. Here's just a regular old jumper wire. It's just a wire on one end and it's got a clip on the other. Clip. Alright, so we're going to plug this in to the positive side of the battery. Jeez, I'm doing a horrible job of this. Alright, positive side of the battery. You're going to have to bear with me, guys. I'm not supposed to be videoing right now. I got stuff I'm supposed to be doing. But I've been meaning to do this for a while, and before I cleaned it up, I wanted to go ahead and put this out there. So, alright. Now we've got a jumper wire to the positive side of the motor, and we are going to take a brush. I've got a brush here, which is just like a replacement brush for anything, whatever. This is a brush. Okay, so we're going to hook our little positive guy on here. Hopefully this thing will reach down in there. Okay, so now we got the brush on there like so. Alright, and I'm going to go down in this hole that I drilled, and we're going to see if it reaches. Whoop. Okay. Well, nope, it don't reach. It was a good thought. Okay, so I also have a diode. This is a big old hunky diode for solar panels or whatnot, but it's a diode. So I'm going to hook this up to my jumper clip. Okay, because my brush wouldn't reach down in there, which I'll mount that in there later. But so now we're going to take this diode and we're going to stick it down in there and touch the commutator, and watch what happens. I get it just right. Y'all hear already it's spinning faster than it was with just the battery? Well, dang it. Ow! Joker gets hot though, boy, let me tell you. Alright, now. This is about frustrating. Guess I need to get the tripod to do this. Wow, look at that thing spin up now. Yep. As you can see, it's spinning way faster. And look at what we're generating. Look at the voltmeter. That's not the joke. Okay, so we're at... That's just the positive from the treadmill motor. Right up behind there. And the negative from the treadmill motor goes to the battery, which the voltmeter is hooked to the negative. So, and then the positive from the battery is hooked to this guy, which I stuck down there on the commutator or whatever. And we're getting, wow, it's holding. It's still reading 32 volts. Probably because it doesn't have a load on it. But it's almost like it's a capacitor. Strange. Why is that holding? There's a lot of weird stuff going on here. I'm not really sure what it is, but there's something funky going on. Okay, so why won't... Okay. Oh, it held. The hold button was on. Duh. Okay, so we're going to do it one more time so you can see exactly what's going on. I need to use something better than this. How about this? How about this guy? Little screwdriver. Don't do this around flammable gases, I'll tell you that. Boy, let me tell you. Okay, that's not working either. There we go. I'll use my little sparkler I got here. Let me set this down. Okay, so real quick, you got 11.87 now on the voltmeter, and on this voltmeter we're reading 0. And we're going to hook up this guy, and I'm going to go in here with this and watch the voltmeter. Well, that thing don't work worth a crap either. But you get the idea. So we're getting a lot of voltage out, and we're putting a little voltage in. So you guys who are, electrical gurus, it's all about the wattage. So we got to check the wattage. So I'll check the amperage coming from the battery, and then I'll put a load on it, which that's another thing. You want to say, okay, well, what does this thing power? What will it run? Well, that's a very good question, because it will run another electric motor. In fact, I've got one that we can put on there. So let me set this thing up so we can do a little show for you. Possibly, if I can set this phone up. I would tell you I'm going to edit this, but I'd be lying. Okay. Let me grab the motor. Hit the fast forward button. Luckily, I have no shortage of motors around here. Okay, we got us a motor here. Fairly decent size scooter motor. Alright, and we're going to go we're going to call this the negative. So we're going to take the negative of this and go right to where the battery is, right to where the treadmill motor is getting its negative from. So right to that bad boy. Same negative. So everything's going to share the same ground. And then the positive, we will go to the positive coming out of the motor. Okay. We got a positive here. It really badly wants to touch. Screw it. Where's my screwdriver? Here we go. We'll go right here, guys. I'll disconnect my other little contraption I got going on over here. And we'll do this the easy way. Okay, positive coming out of the motor. We need to put our voltmeter in line with that. So we're going to go voltmeter here, and then this will be the positive to the motor. And we'll switch this guy over to amperage. All right. And then negative to the battery. What's that? Positive needs to go from there to there. So I'll just do this. I got something. Well, I love that something. Alright, thank you for your patience. So, where were we? We need positive. Tell me that get arc together. We go positive and negative, positive going to this guy. I'm gonna just go straight to it. Okay. Now we need this guy. There's something better to go in there. There we go. Well, guess what? My amp meter don't work. Because we're not getting no connection. I forgot I burned it up the other day. Well, that sucks. And this one's AC only. I'll have to get another meter. Yep. Well, I'll show you it'll run this motor. Then I'll get another meter to test it. And we will also get a voltage reading going to this motor. Okay. Come on. Wow. I don't know if you can tell what I got going on here, but I got the positive coming out of the treadmill motor going to the positive on this motor, negative going to the battery, negative going to this motor, and a jump off the positive going to this jump wire right here. And with this jump wire right here, I'm going to go in my hole here. Wow, look at that thing spin up. if our negative was this, or negative was hooked up, which it's not. I was more excited about the fact that it was spinning so fast. Okay, ready for some action? I don't know if you can see that. If I could hold the damn thing still. So, what we're accomplishing here is not only is without a step up like that thing over there, without one of those, can you see that? It's a little step up buck booster. Without using that, that's not even hooked up. Straight from the battery, 12 volt battery, I can spin up that motor damn near full speed and run this motor at the same time off of the power it generates. And I did a wattage checking, and I used the power supply, and I checked the amperage coming from the wall, and it ended up being about 0.2 of an amp from my power supply to power the motor. And then the power I was generating ended up being around 30 something volt. It came out to about 75 watts. 75 watts. And I was getting I was pulling about 30-40 watts from the wall. So I don't know if this is practical or what's going on here, what the deal is, but you saw I can put a brush. If I install a brush, which I'm going to do, I'm going to take this guy and I'm going to install it right there in the side right here. I'm going to get somehow to mount that in there. I ain't really figured it out yet, but I got a 3D printer. I'll 3D print something or something, and I'll get that brush in there. And when you move that brush, instead of over there, you get it almost as close to this brush as you can, almost as close to this one. So it really needs to be about right here. But I've been going down at an angle like this because that's the closest I could drill. It spins that motor almost to full speed with just the 12 volts. And then from the positive leg and hooked to the battery, it's like you're reusing the same power that's going in, you're getting it right back out. And then some. It's really, I don't really understand it, but it's just, I was sticking something in the motor one day, and it just freaking, it touched in there, and I was like, ooh, that's cool. And I played with it, and I don't really know, maybe I'm crazy. But then the positive coming out of the motor whenever I did it started sparking because it got close to the negative, and it started sparking whenever I was sticking a screwdriver down in the motor to tighten up the other brush. And I touched the commutator, and the motor started spinning, and then the positive started arcing. And I'm like, wait a minute, that's weird. And I just played with it until I found out where I can get it to spin really freaking fast, which it does. If you get it just right in there, that's why I got this kind of bent at an angle, because it keeps grabbing the rotor or whatever whenever it spins. So I'm going to bend it back at an angle like this. And I'm trying to get it to where it's smooth, where it hits, without touching that other brush in there. I got it now. Look at this, guys. 67 volts. Well, that was the max. Okay, that was the max. So dang it, I lost my positive there. There's a sweet spot. Oh, 46. Pretty cool. Can you see that? It's getting a little warm. But it's just literally, I'm touching the commutator in there, so it's sparking like crazy. But I don't know. If you know anything about what's going on here, I'd be happy to have you explain it to me. Or if you would explain it to me, that would be great. I don't know what the hell's going on. I wonder if it'll run that motor. Meaning it'll run both motors at the same time. The same size. That one is a 2-point-something horsepower. Let's do that. I want to run that motor. I wonder if it'll do it. Technically I was... Technically I was getting more amperage out of it than I was putting into it last time, but so it should run it better. And even though I'm running off 12 volts, it's getting a much higher voltage out, so it should spin this motor up faster also than just the 12 volt motor battery alone does. Because just the 12 volt battery alone, remember, don't spin this motor with a crap. It's a 90 volt motor, so it don't spin it hardly at all. So just from doing this, not only can I spin this motor faster, but can I spin another one of the same size? That would be cool. Well, hold on, let me look this up and we'll see. Alright, got the positive and the negative hooked up. Let's put our little jerry-rig brush in here. Let's see what happens. I'm gonna bend this right. Alright. Jerry rigging, here we go. Let's see what happens. Wow. The same speed exactly. I don't know if you can see that or not, but it's spinning the same speed. As soon as this motor starts, that one starts. That's cool. Wow. It spins up both of them. Holy cow. And what is the voltage drop on our battery here? After all that, what's the voltage drop? Because that should have damn near killed that battery. I mean, it was dead. I brought it back from the dead. Okay. It only took 3 freaking days of pulse charging it to bring it back to life. And with low voltage AC, not DC, AC. Crazy, right? Well, I was reading a documentary on electrolysis, hydrogen machines, and a guy basically used a battery to do electrolysis, and he used pulsing AC, and it kept the lead in them from oxidizing. So it made sense to me. Well, will that knock the oxidizing off of a battery? And I tried it, and it worked. It worked, just low voltage AC pulsing. Anyway, different topic. 11.77 volts. We were at 11.97 when we started this. So 0.2 volts. After all that, playing around. So definitely something interesting going on here. And just to show you real quick, I'm gonna hook up just the see, I had basically the positives to each motor hooked together and the negatives to each motor hooked together and hooked to the battery. That's all I had. And then I take one jump off the positive and go inside here, and both of them spun up at higher speed than the 12 volt alone does. What the hell? That's weird. Okay, so we'll put both of them straight to the battery and watch the difference and what it'll do. So we got this guy. Okay, there's this guy. I don't know if you can tell, but that thing's barely spinning up. Okay, that's both of them. That's that one. It's not even screaming really. And then there's that one. It's spinning so slow you can see the shaft was bent. It was spinning way faster the other way. And already right there, that's 0.7. Okay, so the battery is actually holding voltage pretty good, which is awesome because that thing was dead as a doornail. I had 0.02 volts on it when I started trying to fix it, so that's pretty cool. That's exciting. I got a lot of batteries I'm going to try that on. But anyway, if you caught what I'm doing here, great. If you can make use of it, great. Have fun with it. If you got an explanation of what the f is going on, I'd be happy to know. You could share that with me. That'd be great. Other than that, thank you very much for watching and being patient if you made it this far to see that. And I've got some cool stuff coming up, like this motor here. I've got my new controller that I've had for a little while that I finally got going, which is a freaking hidden gem right here. This little, who has a baby little controller like this that will spin that motor up 2,000 RPM? That's a big 12-inch motor. And watch this guy. Is that epic or what? Listen to her scream. This little itty bitty controller. Itty bitty little guy. Super tiny. Look at that joker. And we can literally fine tune it to any speed we want. And it does great under a load. Any speed we want. I put this one and this one. Oh, this is the 1 horse. Brush this DC motor on there, which they're actually AC motors, but they have built-in inverters on them. If you saw my other videos, you know about these motors. But I put this on there with full load on it, using it as a generator to power this little wind turbine controller, which is an MPPT charge controller, so it starts charging right away, and hooked it to the battery. And when you hook this motor right here to, or either one of these, to that controller right there and try and turn it, let me tell you something, it's not easy. Like, I can barely turn it by my hand. And this thing right here spins up probably about 1,000 RPMs, maybe a little bit more, at full blast. So it's not the most powerful controller in the world, but that's impressive for such a little package. And it's got a built-in fan on it. I mean, you can use that thing if you have a 12-volt battery like this, an inverter like that, and that, because it's 110 volts in, up to 240 volts in. So if you have a little battery like that, a little inverter like that, that's a 1,000-watt inverter, and then this little guy right here, which is not a ton of stuff to put on a bike or something, you could have a motor like this on a pretty impressive freaking little ride. That thing only uses, under full load, it only used 150 watts to spin this thing up to full speed. So, crazy impressed with that. Right now it is censored. I've got sensor wires, or sensors over there, but there is a way to program it to be sensorless, but I don't have the programmer yet. So when I get the programmer, I'll do a video on that. But pretty cool. That's a whole other topic. I was going to do a video by itself for those two devices right there. So maybe I'll do that soon. But I've got to clean this stuff up. And I just wanted to share a little bit with you before. Oh, look at my voltage jumped up. 11.8 now. Battery back from the dead. Cool thing to do with treadmill motors. And pretty awesome controller. So, thank you guys for watching very much. And if you know anything about these treadmill motors and what I just did, and you want to help me figure out what's going on with it, please share it with somebody who you think will know, or if you know, comment. I would greatly appreciate it, and hope you liked it. Thank you.